Okay, so here are our mixtures A, B, and C, and here are the cups of liquid that they produced, mixture A, mixture B, and mixture C. Now notice that mixture A made a much larger drink mix, and it's going to taste quite a bit stronger. Here's why. On the double number line diagram, we see the 1-to-1 1-to-1.5 relationship at the first tick mark. Where do we see that relationship in the double tape diagram? In the table? Well, let's take a look. We can see that in mixture A, we have 1 cup of water, that's right here, for a tablespoon or a teaspoon and a half of drink mix. And it looks like this on the double number line diagram. Now that means we're counting on the drink mix line by 1.5. So for 2 cups of water, we would end up with 3 teaspoons of drink mix, which is noted here. Now let's take a look at mixture B, which was 2 cups of water and a half teaspoon of drink mix. We can see that we have less drink mix, but more water. And here's the cool part. On the double number line, if we split 1/2 into 2 equal sized groups, we end up with 1/4, which we can also see in the table here. 1/4 teaspoon of drink mix for 1 cup of water is an equivalent ratio to 2 cups of water to a half teaspoon of drink mix. I can tell because if I double the water or multiply times 2, and if I double the drink mix or multiply times 2, I end up with mixture B. We can see that both mixture B and mixture C appear on the double number line. They are equivalent ratios, which means they taste the same. There's the same relationship between water and drink mix. Now, on Class Kick, we're going to skip slide 1.3 and just take a look at the summary. The summary says, when 2 different situations can be described by equivalent ratios, let me get my highlighter. Equivalent ratios, that means they're alike in some important way. So for an example, a recipe. If 2 people make something to eat or drink, the taste will only be the same as long as the ratios of the ingredients are equivalent. So for example, in this table, all the ratios of water to drink mix are equal. But if a mixture were not equal to these, for example, if a ratio of cups to water were 6-4, so we'd be doubling the water from 3 to 6, but we'd be quadrupling the drink mix, then the mixture would taste different. Go ahead and take a look at the exit ticket in today's main folder to see whether you've mastered this concept. When you're finished, make sure you take a look at tonight's homework assignment, which is also posted in Schoology.